The first one, and they relate to MBS, but they also relate to MBMS. And I believe I like it that we kind of avoid to fragment this. At the end, I think we should converge even more, but okay. In-session unicast repair for MBS, MBMS object distribution. So there's CRs here for stage 2 that only goes to MBS. And then there's a stage 3 for MBS, and there's something for MBMS as well. There's no stage 2 equivalence because MBMS is the spec is a mixture of stage 2 and stage 3, I would say. Okay, so what was done? What was identified that for live and low latency using the object distribution method, in certain cases, the transmission of an object is not successful. So, for example, a dash segment is lost, you lose one packet. In this case, unicast repair for individual MBS client can improve the service quality. But you need to take care of the timing of such requests, need to be carefully studied in order to avoid network overloads or significant latencies in delivery. And that was identified in the technical report. So the first thing what was done, we created a new reference point that didn't exist, which is MBS 12, that allows that whatever is ingest through MB8 and MB8, so for example, this would be dash segments, that they can also be stored for unicast distribution or provided for unicast distribution here. So I mean, you could also do it the other way around, that you ingest into a unicast server and then pick what you have here. I believe that's more an implementation choice. But as we had MB8 and nothing here, this is like this. I mean, you could also put the 5G media streaming, and we know that AS could be physically co-located and be the same function for a 5G media streaming AS and an MBS AS. And it's just exposes different interfaces. But logically, it is for the purpose of supporting the MBS client. And then we basically added the procedures for user service provisioning, and we added the document call flow for both post and in-session repair. We didn't have the post-session repair. So post-session repair was already defined in release 17, no, it's live 17, and it was defined because post-session repair was also present in MBMS. So it was kind of, and there was an agreement to align this. And there's a bit of a history. The post-session repair, we tried to kind of port this from MBMS in release 17, but there was quite a problem in a sense that this was written very MBMS entangled. So what we decided is to rewrite this in MBS and basically only technically align this, but the description is independent. I'm not a fan of duplicating things, but in that case, it was really, in my opinion, impossible to generalize the MBMS. Now that results in a bit of a hiccup, and it's not that bad, but it looks a bit weird for release, for stage C, release 19, so I get there in a second. But this was basically defined. This is stage 2. And stage 3 now, so we extended 2 specifications, MBS and MBMS, so 26517, that's MBS, that's the stage 3 protocol here, and MBMS is 26346. And what you need to understand is that what is now the case, the MBS spec owns the repair protocol, so that's defined here. And the MBMS owns the multicast delivery protocol, so the download delivery protocol, delivery method, so the flute distribution. And as we support both in both services, there's some cross-referencing happening. And I believe it's better to start here on the right-hand side, because the right-hand side would more or less explain what we're all familiar with. So what we have done, we extended the FDT to provide session repair properties per object. And you can add two values that are per object. And one is, it's a repair start, and it's an earliest date time at which unicast repair may be restarted for the file object described by the FTT instance. So that is more or less a segment availability time equivalent. So you say, when can you start these requests? And then there's another one, which is referred as repair limit percentage. That prevents that clients who are in bad coverage situations overload the network. And you can say, over the last 100 objects, you allowed to do repair for 5 or 8 objects or 10. If you have exceeded this, stay away because you're overloading my network. I mean, you can keep it to 100 and default, then that would not cause any issues. But it's kind of preventing that clients that are in a bad coverage situation overload the network. Then we added a second topic into the delivery protocol, and actually it's associated with the flute announcement in the STP. So what we added is that you can specify sending rules that you use on the sender. And these two sending rules, you can say, client, I let you know that I use a specific sending rule. First of all, I'm using an object sequence number rule, meaning the TOI can be interpreted as a sequence number. So I'm incrementing this by 1 with every sent object. That allows you, for example, to detect missing object. That also allows you, if you get a packet from a new TOI, you know, okay, so this is the next one. And there's a second one that says, I'm sending objects sequentially, meaning I'm only sending packets for object A, and and then I'm sending only packets for object B. So they're not interleaved. Okay. That allows that you can more easily detect, for example, when an object sending is complete at the receiving end, because that's not trivial, right? You don't know, will I ever get object? So this allows to detect this. So that's why this was one of the reasons to be used. And this is done many times, but the client is not aware of this. And the third one is now the in-session unicast repair. And for this one, we predominantly only refer to the MBMS protocol. And what we have is there's parameters that need to be defined, and you can signal these parameters on the session level because you might not send this for every object. So you could basically say, I assign this to the session. There's one error, a copy paste error so the repair start in the session is not the earliest state time. You can derive the earliest date time, and that is basically by a delta from, I believe, the first packet you receive, you can create a delta. So, and then there is also this percentage you can signal as well, and make this a global parameter to not send this in every FTT. The second one is the procedures and requirements, how to do this. And then you map this to the MBMS client and the BMSC, what they need to do. But this is then basically by reference. What has been done in MBS, we define the in-session repair. We do the signaling of all the parameters. So basically that includes the repair start, the percentage, and all of the URLs where you find it. So how do you use the FTT URL? You do a resolution, and then that gives you a reference to the ES. The second one is the in-session object repair procedures. So basically there's general procedures and there's the parameters to define. So the parameters are either coming from the FTT or from the in-session repair. There's the URL. So these are all generally defined. And then you have something that you need to do. You need to determine that you're not able to complete the recovery of the object. And that's kind of a bit of a challenge because you want to do this as early as possible. And you want to do it also as late as possible, right? So if you can recover the object by FEC, you want to do it. But if you detect that it will not be possible, you better start repairing, right? Because these are all time crunch things, right? So that's why the sending rules are important, because that allows you to earlier or more deterministically determine whether the object can be completed or not. And then there is the request protocol. So how you access this. And actually, in contrast to post-session repair, where you're required to operate with byte ranges to just work with the FEC, in this case, we identified that it's better to allow that you can request the full segment. So meaning you might not fill the hole, you can actually request individual segments and just basically do this. What is the benefit here? You can basically route that request directly to the application, right? So this one will then basically be directly proxied to the application. And even if it's not complete, it might give the application the data. And so that is easier. And then we map this also to the MBS TF, what you need to implement in the AS to support these general procedures. Okay, the last point is from an implementation perspective. I believe it may be first interest for 5G broadcast, which is much closer to the people use it also for trials. What I learned last week, and actually it was not last week, it was the week before last week, because that slide I did before at the MPIC meeting, that GPAC already implements this for DVB NIP. Interesting, so they refer to this. So the work, in my opinion, would be in the transmitter update the service announcement to add the SDP, to add to the SDP the sending rules, signal in-session repair parameters on USD's level, signal in-session repair parameters on the FTT. And you can choose, not both of them need to be done. Maybe that's a simpler. And create a mapping. That's more an implementation for a dash MPD. And this type of information to the FTT. So basically aligning the timelines, right? And on the receiver end, you would read the service announcement for repair session parameters and implement the protocol for in-session unicast repair for dash streaming as an example. It's not exclusive to dash streaming. That's it. And I see there's questions, which is good. But okay, thank you.